on Wednesday of last week. As always, like I always begin, make sure you have the proper software installed. So make sure you have Node installed. Download the LTS if you don't, and install that. Have an account on Turbo. Make sure you do that. It's free, so don't worry about that. Yeah, and that's it. So on Wednesday, we set up the resume website. Let me see if I can punch up my version of it. Okay, so we set this up on Wednesday. We didn't get through all of it though. The main thing we did was we populated these values with the placeholders from the JSON files, right? And we covered most of them. There's most of them on the upper right corner at least, and some over here. But the stuff down here from experience and projects and references, we didn't even touch that. And that was because it was a different kind of data. It was more dynamic data. In this case, it's actually database-driven data. This data right here, experience, so basically your job history. It's more dynamic in the sense that, like, your job history is going to change a lot over time. Hopefully you're going to get more jobs down the road, or you're going to get a promotion, something like that. And that certainly should be the case for projects. You should be adding more projects, and that data lives in a different part of the website than the other data, like your name and your icon, stuff like that. This data lives in a database. It's a different source of information. So we now have to set up rendering that data as opposed to the JSON data, the template data. It's two different things. So it's important to understand kind of when we're dealing with what kind of data. Does that make sense? So the stuff we were doing on Wednesday, it's essentially configuration data, just like page configuration stuff, your name, your image, your title, stuff like that. But the stuff we're going to work on today is the meat of the site, the database data, the database-driven data, okay? So let's go ahead and get started on that. I have my terminal already open. I'm going to cd to the root level of the project, which is this right here. And here's the project on my desktop. I'm going to open that up in VS Code. So just slide that over onto VS Code and open that guy up. You don't have to do this. I'm going to do it just for good measure. I'm going to remove the node modules and reinstall. Again, I'm just being like super cautious here. You don't really have to do that. But I'm going to install the dependencies and do a clean install. Run it locally. Make sure everything is where we left it, basically. And then pick up where we left off.
And so I did that, and then uninstalled and reinstalled the Vertex 360, and it updated properly.
Okay, cool, great, excellent. So you're all set to go. All right. Okay, so I reinstalled my modules. I am going to. This is a weird VS Code thing, but it didn't show up here, so I'm just going to reopen it. Or it's probably my computer, not Visual Studio. Okay, so here it is, and then if you open up package.json, you're going to find a script called dev, and that's the local host script. They're running the local host. So we go to the terminal and we do npm run dev, and again, all this should be review. I'm just sort of reinforcing the stuff we've been doing again and again and again. And I'm now running the project locally on localhost. This is called a port number 3000, port 3000. So like I said, every time we kind of redo a lot of this stuff, I'm going to just sort of add a little bit more detail that I didn't explain last time. So this is a port number 3000. Websites, computers in general, you can serve data through what's called a port. For most websites, the main primary port is 80. For localhost, oftentimes it's 3000, 8000, 5000. Those are like the main ones. Different kinds of services use different ports. So for example, like Mongodb has like a different port number. I think it's 2717. MySQL has another port number. It's like 6203, I think. Like over time, you just remember what uses what port. Okay. So we have localhost running, and here I have localhost 3000, and it's showing the same thing. So we're in business, good to go. we can basically pick up where we left off. Okay? Everyone with me? Raise your hand. Yeah? Kia, you good?
Yes.
Great. Awesome. Okay, turn off the server. We're ready to rock and roll. Let's get back into where we were before. So I want to continue working on this page right here, right? So who remembers where that page is in the file structure, in the file tree?
You mean like views?
Views, and then, well, there's only one view, right? The home.mustache. And so that's got to be it, right? And on Wednesday, I keep saying Monday, we started filling out this dynamic data with the template configuration in the JSON files. So we did that. I assigned this as more of a homework assignment. Yeah, we'll touch on that for a minute, and then we'll move on to the dynamic data. So I'm going to just finish out one or two more of these, like the LinkedIn one. If you look at this templating engine syntax here, what that's showing me is that the global.links.website.show or hide is where that data is being sort of determined. So I open up the global JSON file. There's going to be a links.website and then .show or hide, right? And the one above that is global.links.email, etc. So the one beneath that should be global.links.linkedin, and then etc., etc. Basically, we got to add an entry for LinkedIn, right? So I'm just going to do that real quick, just to sort of continue this process. And that's going to be an object entry, a nested object. I'm just going to copy and paste from one of the previous ones. And then the class right here is going to be, well, LinkedIn. The icon is going to be all this stuff. Let's just say LinkedIn for that. And then the value will be just LinkedIn. I think that's one of them. And that's going to be what actually shows up on the hyperlink. Okay? And then we're going to just put that inside the templating engine. So this should now be LinkedIn. And before I continue, who remembers what this hashtag right here and slash right here, like what is that all about? Like who remembers what that's doing?
Nesting.
Not quite.
Just telling where to start and stop, right?
Yeah.
Close. This is kind of like one of the last things we did on Wednesday, so you might have just forgotten because we just sort of touched on it before the end of the day on Wednesday.
I know it's when you use that when you're doing the when you're doing the show or hide.
Correct. What does that mean right here?
To show, so that'll take you back to the global JSON in case you want to either show the link that you have or hide it. Like if you don't have an Instagram.
Well, what if I want to hide it? What do I do?
If you want to hide it, then you would go back to global JSON and you would put false.
Very good. Exactly. And then it won't even show up.
Right.
Okay.
Right,
Good.
but that's telling it where to look for that logic, right?
Yep.
The hash and
Right.
stuff, yeah.
That's it. So that's the mustache templating engine. Okay, that's part of how the mustache templating engine works. Okay. So we just take this and then class, and then we just fill in the values, and that's
Because anything you put in between those two, right, it'll hide it if you have it as true or false.
Yeah, it won't even show up.
Right.
Correct.
But I mean, like if you were to copy everything below it, put it between the show and hide.
Yes, that's fair. That's accurate. And you should take advantage of that as much as you can when you're doing your template rendering. It's very helpful.
Put that for each line. I didn't have to put it for each line.
No, you did. You did. You were correct.
Oh.
Nicole was just offering sort of like an example of making sure she understood the concept. But you really were supposed to go through each one, and that's correct. But before I hold on, URL, and then value, right? Yeah, value. Okay. So now if I load the site, and then reload, it's going to look the same, right? But let's actually illustrate what Kia was saying. If I go back here to the global config and type in false instead of true, this is for the LinkedIn entry, then this right here hopefully should disappear when I reload, right? And it does. That's exactly what you were articulating. So good. Let's go ahead and put it back. Okay, and you know what? Just to get it in there, let's for the practice, let's throw this up on the staging environment just so everyone just gets in the habit of doing this. Okay, so I'm going to do a quick turbo deploy. Make sure everything still works on the hosting environment. And Kunle, for your own just enrichment, what's happening here is we're creating a Lambda function, we're uploading the source code, we're connecting the source code to the Lambda function, and then connecting that to the API gateway, which is already connected to the reverse proxy. All that's happening right now. And then when it's done, the site just runs. You see how right now there's about a 5-second delay between deploy complete and then it returns, about a 3-second delay. In those 3 seconds, all that just happened. So then this,
$0 almost.
right? And now it's working here, right? Now, let's see. Notice here, this stuff is already not showing, like the LinkedIn is gone, right? Like it may seem like something went wrong, but what happened was we edited the global JSON without pushing it to the server. This data is not on the server, it's only local. I deliberately decoupled that data so you can't like mistakenly mess up the server. So what we need to do here is we do turbo page global to update the global page on the server. And that should sync up your server with your local hosting environment. Now what we have on the server is identical to what we have on our local hosting environment. And if you were feeling particularly not coding inclined a certain day, you can actually go to the site here and manage those config files just visually. Don't worry about the appearance. I'll show you why it's doing that later. But you see how it's this stuff shows up? Links, and then email, website, LinkedIn. This is the global config we just posted. Does that make sense? So I can set this to false from here. I just set LinkedIn to false. I press apply changes. That's just doing the same thing as turbo page global. So if I go back to here, I set LinkedIn to false. So this should go away, and it's gone. So you can just do that visually too. Okay. So these config files right here, these config files support the data for this visual editing module here. Okay. So if you're just, for example, let's say you found a typo. You spelled your last name wrong or something like that. You don't want to open up Visual Studio, open the code, and fix you can just go here and fix it right away. That's one of the main benefits. Again, this is a turbo thing. This is not a Node Express thing, to be very clear. Okay, so what turbo does is it sprinkles in a few extra features to make your life easier, or at least my life easier. This has certainly made my life easier a lot. So sort of the impetus behind this was like, you put together a quick site for a client who's running like his own law firm or whatever, and he's like, oh, can you just change this wording over here? That's a quick 5-second fix. You don't want to have to open up your code and do this and that and the other. Or you could even just tell your client, just log in there and you can just open up those config files and change it yourself. That's really the idea behind that, okay? Alrighty, so let's get back to the original plan for today, which was getting this dynamic data to render properly, or at least manage it. So we have dynamic data in the form of experience, projects, references, skills. We're going to just focus on the first two. I'll leave the rest for homework. So experience is basically your job history, what jobs you've had in the past. And projects are exactly what they sound like, whatever projects you're working on. So for me, that would be Turbo. This is database-driven data. This is all data that lives in a database on the server. in this particular case, we are provided a local database with which we can experiment and see how things are connected. Okay. Trying to think of the best sort of concepts to begin with here. So, in general, databases are, one of the top 3 most important things you're going to study, kind of in programming and overall in web development. Databases break down to 2 primary categories. There's what's called a relational database, like MySQL is a relational database, and then obviously non-relational database, sometimes called NoSQL databases. The distinction between the 2 is simply how the data is literally stored. Okay, a relational database, the data is literally stored like you would see in Excel spreadsheet, tables and rows. And the data is stored in, columns and rows. That's a relational database. So SQL stores its data in that fashion. And a non-relational database, or the most common kind, which is called Mongodb, uses what's called a document style storage, or document storage system, where the data is not organized in columns and rows. An entry in the database is really like a document. It has in this case, a profile, whatever, name, an email, first name, last name, email, social security number, age, etc. And it would be like a document. And that's the primary distinction. Okay. There's a lot more to it, obviously. I'm not going to go too deep into it, other than to say they both have their advantages and disadvantages. What's important to understand is the primary distinction between a relational and a non-relational database. Okay. So the most popular relational database is MySQL and PostgreSQL, which are both are SQL-based databases. The most popular non-relational database is MongoDB. There are others like Redis and others. Dynamo is pretty popular. And they all kind of work the same way. The documents in a MongoDB or most non-relational database structures are just JSON files. Okay, they're just JSON files. So fundamentally, this file right here, home.json, could theoretically be a document in a database. Okay, they're just stored as raw JSON. Okay, so you can quickly see right away like why a document-style database or a NoSQL database became popular, because the data structures are already in such a way that jives well with JavaScript. Like they're kind of meant to work together, right? And so among other reasons, that's one of the reasons why a NoSQL database, a non-relational database, is a very popular choice. Turbo doesn't use any of the major databases. It uses what's called a local database, which basically mimics the Mongo database. It's a very, very, very close approximation to Mongo. I would say about 95%. The reason that is so that you can quickly spin up and deploy a Turbo project without worrying about an actual enterprise scale database. Okay. To give you some quick sort of theory behind it, it uses a local storage mechanism that's very similar to what's called SQLite 3, SQLite 3, which is the same thing in SQL, which basically runs a database, quote-unquote database, locally on your server instance, as opposed to a dedicated database cluster, some enterprise scale database like on a different cluster. Is that architecture good for like a commercial grade website? No, but is it good for like your blog, my portfolio site? Absolutely. So like a simple local database, especially like SQLite 3, if you're processing like up to like 100,000 queries a day, it'll still do fine. Once you get into like the millions, you're taxing its limits. But 99.9% of websites don't even touch 100,000. So for something like this, the way we set it up here is fine. The important takeaway here is understanding how to set up data, structured data in the database, because that is exactly how you would do it in Mongo, or very close, 95%. Okay. So that's a quick overview of how it's organized. Now, database data is organized into types, generally called models or schemas, more accurately, schemas. A schema is just a definition of a data type. So, a very obvious schema would be like a person schema, profile schema. All people share certain characteristics, just regardless of where they're from or whatever. All people have certain characteristics, namely, they have a date of birth. Right? You have to be born sometime. They have like a name. Everyone has a name.
So schema shares commonalities?
No, a schema is like the definition of what makes a person, right? So, like what makes a car? Like a car has a make and a model, a year. What other attributes are unique to a car? Miles per gallon, mileage. Is it what country is it? The country of origin, I guess. These are the attributes that, taken together, make a car, right? And that would be the schema in a database, right? Another like quote unquote schema in real life would be a company, right? Like a company, like a Fortune 500 company. Let's say a company like I don't know, Bloomberg. Well, that's not a good example. Facebook, right? Typical Silicon Valley company, right? What are the key characteristics of that company, right? There's a CEO. There's the name of the company, the name it was incorporated, the location where it's incorporated. Is it public or private? Privately traded versus publicly traded. But some of these attributes wouldn't apply to like a car. Is a car publicly traded? That makes no sense. So that schema doesn't fit. It's unique to a company. Am I making sense?
So it's like the unique identifier.
No. So a unique identifier is something else. So when you have a database schema like a company, and you create a new company in the database, it should be assigned a unique identifier. Generally speaking, that happens automatically by the database. Almost always, that's the case. It's some long random number that's like impossible to like regenerate by coincidence. That's a unique identifier. As American citizens, we all have a unique identifier. What is that? Social Security, right? That's your unique identifier. It's only one person. It's only you. There's no other person who shares it, right? And it can never change. Like, sometimes people say like your phone number, which kind of is true. But like, let's say one day you just change your phone entirely. You change service. You get a new number. Well, your old number could theoretically go to somebody else, right? That would never happen in a database, and that also couldn't happen in your Social Security number. So that's a unique identifier. The schema is all the attributes taken as a whole, which constitutes a certain category of data, right? So when we're writing out like our database models and whatnot, basically we're responsible for defining schemas, okay? Now, we're not going to do that today because it's already written out for us, but I want you to understand what you're looking at when I drill into it. So in this models folder, you're going to find the schemas that are predefined in this project, okay? So there's only one, job. So we are going to do it today. I deliberately tore out one, but job. So all this commenting over here, feel free to leave it. I'm just going to remove it because it's kind of in my way, but you can leave it if you want. So the schema is literally, again, the attributes that define the data structure. If you look here on line 15, my line 15, you'll see that I'm defining a class called job. So the name of the structure is called a class. That's an important concept, a class. So right here, I'm defining a class that we're calling job. And a job, we then define the attributes, aka the schema, which taken as a whole defines a job. Okay, that schema is everything you see here in lines 4 through 12 in my code. It's probably different in yours. Everything to the right with the curly braces, just ignore that. And if you look at everything to the left of the colon, you'll see pretty obvious attributes of a job. You have the position, like what are you? Are you an engineer? Are you a salesperson? Whatever. The company, obviously the name of the company. Location. Now this is a job as it pertains to your resume. So then there should be like a start date and an end date, right? When did you start? When did you end? Right? So this is a job schema for the purposes of a resume website. So you want to define the attributes that you need for your resume. Okay? And then a description, so like what did you do at this job, right? Make sense? And then the last three, these three, these are just default properties that everything should have. Now you don't have to put them there, but it's good practice to have those properties. Like the timestamp is when a particular entity was created. The date string is just a human readable version of a timestamp. Let's worry about that later. It's really not that important. The important things are right here. Okay? That's where your discretion as a programmer comes in. So maybe you're like, I don't care about the start date and the end date. I just want to list the jobs. So then what you would do is you would just take these two out. Okay, and that data will never be stored. Okay? Now let's focus on the curly braces to the right. Every attribute has a data type. Literally, in this case, it's called type. I think you can kind of see, well, they're all one type, so this is not the best example, but you can kind of see how they relate. If my position, at XYZ company is a software engineer, right, then the value of the position would be software engineer. The literal verbiage there, it's called a string, right? It's a text string. That's called a string. That's the data type right here, string. Okay, as opposed to say a number. So like let's say there's another attribute here called wage, my hourly wage, right? The type, let's say I make $10 an hour, $15 an hour. The type wouldn't be a string. What would it be? Number. And you see that's where the types come in, right? Another type might be.
So it doesn't be like floats, all the other descriptions of numbers.
Not in this case. Actually, I think this one does support float and double. Yeah, I can't remember to be totally honest, but number kind of encapsulates all of it. I'll have to look up the documentation on that, which we can just do right now. Like I think it does support float, double, and integer. So data types. No, these are the types that this database supports. Okay, so where was I? Another one might be like, I don't know, a list of colleagues, I don't know, partners, right? And let's say that's literally a list of people you work with. So what would that data type be? Array, very good. Right, it wouldn't be a string because it's a list of people. Obviously it wouldn't be a number, it would be an array, right? And let's say another one might be is, is CEO. And that would be just true or false if you are the CEO. So what's the data type? Boolean, very good. Right, and this is how you set up schemas. Okay, so if you want to add a property, you would do it this way. Okay, in this particular case, it's all strings. So it's not like the most, holistic example, but the concept I think is pretty understandable. Now, oftentimes a person might enter data without fully defining all the attributes, especially if you're entering data from like a human interaction, like somebody's filling out a form. Very often people will fill out, like not fully fill things out, right? And that's where the default value comes in here. So basically, when you create a job in this situation, if you don't fill out the position, the database here will automatically fill in the value with that empty string, right? You could also set that to none, like whatever you want the default to be, the database will honor that right there. Okay? Make sense? Don't worry about display true yet. I'll show that in a few minutes. But for now, like those are the most important things: the data type and the default value. Okay, a couple other small. I'm sorry, you had a question?
Yeah, I was gonna say, can I just remove the whole default word and the brackets?
Oh yeah, you could remove it entirely. I think.
So it's not necessary.
Yeah, I think in that case, if somebody enters a null value for position, it'll just literally be null, right? There are a couple other attributes worth noting, just for just so I cover some bases here. Let's say we're filling this out in like an actual input field form, right, on a website, right? Very often what happens is somebody will fill out a form, right? They'll fill out data like this, and they'll leave a trailing space behind right there. And that will go in the database. That will get stored. We don't want that to get stored. So the way you would prevent that is you do trim equals true. And it'll automatically shave off any trailing spaces or anything like that. That's a nice little feature. Let's say somebody puts in something like www.google.com. For whatever reason, he just had uppercases when he shouldn't, and he just forgot. I don't know. He's careless. You can also sort of normalize all that. You can prevent all that by doing lowercase equals true. And that'll automatically take whatever string and lowercase it, just no matter what the user enters. Okay. And conversely, you also have the uppercase option if you want something uppercase. For example, you might have an entry saying like, list your city and state, right? And somebody puts in Baltimore, Maryland, right? Or MD, but lowercase MD. But you want to have all the states uppercased in your server, in your database. You would just throw that guy in there. And that'll sort of guard you against a lot of like sort of weird like human nuances that people don't know they're doing and stuff like that. Okay?
Would you make everything uppercase or just the first letter?
Everything. You're thinking capitalize.
Oh, okay.
That's the other one. So okay. So a couple little features right there. And yeah, and here is where the actual document schema is defined. And notice it uses the word document right here. And that's a direct reference to the document storage architecture of this database. Okay? Just to make it a little bit more kind of directly visible. You could also fill it out like this. I don't know, that might be easier to read. You see on line 7 it says this dot schema, and then we're just passing in the attributes. Okay? So that's how you, I'm going to just put it back to the way it was before. That's how the job schema is defined in this particular site, in this particular resume website. Okay? So if you go back to the actual site itself, these are the values that are entered in there for each one of those. So this would be US President. Which attribute would that be? Position, right. Well, I was never US President, so let me just change that. The original template was John F. Kennedy. So instead of changing this, let me just add a job. But yeah, this was President. What about, I'm sorry, position. What about this? What is this? Start and end. So that's actually, you're looking at two attributes right there. Start date, end date. Okay. What is this? Yeah, do we have location in the schema? Yeah, we do. All right, yeah. Location, and then what is this? Description, right? So we pretty much used all of them, except maybe company. Company would be this,
Oh, and then Washington DC.
and that's location. You with me? And that's how you, so when you're looking at database-driven data like this, you should always be thinking along the schema. It's like, where do you think that fits in the schema? And like you're kind of seeing the data behind it, or you're seeing one level deeper than just looking at a website. You should always be thinking that as a programmer, okay? Even on just regular websites, just your own stuff. Just, you go on ESPN.com, you should be thinking like, all right, how are they putting this together? Where are they putting that? And it kind of helps you learn how things are done, okay? So that's the schema. This is the model. Let's keep on maintaining focus on the job. You may recall last week I said that the data is manipulated through files called controllers, okay? So the way this is organized is every model here has a corresponding controller. In this case, there's job controller. And the controller handles what's called the CRUD operations: create, read, update, delete. Okay? So whenever you want to create a job, you do it through the controller. Whenever you want to remove a job, you do it through the controller, and then update and delete. Now, not everyone does it this way. Sometimes people put all the CRUD operations in the class itself. I've seen that too. Okay, it's kind of two different ways of handling it. So I want to draw a distinction there, saying this is more my personal preference, but it's not like a weird thing that I just do. A lot of people do it this way. But in my work, I've also seen it done where developers will put all the CRUD operation in the class itself. Okay, so just be ready for both. So here, the way it works is all the jobs, all the CRUD operations are mapped essentially to an HTTP request. Who remembers what the 4 request types are?
Post, get,
Delete, update.
And last one?
Put.
Very good. So get, post, put, delete. I mean, there's more than that, but those are the 4 that really matter. Each one of those maps to a CRUD, one of the letters in CRUD. So you should think, from now on, you should always be thinking one of those methods with one of those letters in CRUD. So the get corresponds with what?
No, just the R.
It's not in perfect order, guys. Think it through.
Update.
Get.
Create as post.
Get is read, right?
Oh,
Get means so start thinking of those two as like the same word. Okay, so get means read. So we got the get covered. What's the other one? Post. What is post?
Update. No, sorry, create. It's create.
Great. Post and create are the same. Just start thinking them as the same. They're synonyms from now on. Okay. What's the other one? Get, post, put,
Put is
update, and delete's the only one that's obvious. So that's the only one that's a perfect match. Okay. So start cementing that in your head. Okay. So these methods right here are mapped to their corresponding HTTP verbs, HTTP methods. Okay? So on line 10, you can see this is a get query. I'm getting a bunch of jobs based on filter parameters. And don't worry so much about this yet. I'm just sort of going through a high level of like kind of how this is organized. Get by ID is the only one that's not a perfect one-to-one mapping, but you can kind of see what's happening here. Here's where the unique ID comes into play, Tina. If you have a specific job that you want to find, let's say, Nicole, what was your first job out of college? But there's only, sorry?
Research scientist.
Yeah, there's only one job that comes to mind, right? right? That's you just performed a get by ID in your head, right? That you're looking for one job in your head, and that's a get by ID. You're looking for one thing in particular, and you're using the unique identifier to specify which one, right? And that's a get by ID. Another good example is like a fingerprint. Like we found a fingerprint in a crime scene. We're now going to find the criminal because we have a unique identifier, and that's a get by ID. Okay. This post means this block of code here is going to do what? Post corresponds with create. So what's going to happen in that block of code?
It's gonna
Create a what?
The file, the data?
What controller is this? Mm-mm.
Is it creating the post?
Mm-mm.
It's the job.
Job. We're creating a job here. Okay. This is a job controller.
Oh,
Gotta maintain the context, right? So this has nothing to do with blogs. In fact, there is no blog on this website. There's only a job, right? So this block of code from lines 45 through 62 is going to do what? We just said it.
Create a job.
Create a job. Good. Keep it simple. Create a job. Okay. Line 64 through 79. What is that block of code going to do?
it's gonna update the information, the job,
Update what?
the job.
A job. Right. It's going to update a job. Let's say you're going through your resume and you're like, oh wait, no, I worked here until 1961. I have to make an update, and that's going to happen through this chunk of code. This chunk of code will perform that update. Okay, and that should happen through a put request, a put HTTP request. Okay. And last but not least, let's say you want to hide a job because you got fired and you got a bad reference, and you don't want that to show up on your resume, so you delete the job. Right, and that's going to happen through an HTTP request called delete, a delete request. Okay, this is one of the most important concepts of pretty much everything I'm going to teach you, so make sure you really understand this. How to manipulate database data through HTTP. Okay. Now, not to throw more acronyms at you, but this whole thing is under the umbrella of what's called REST, like taking a rest, and that's an acronym. It stands for Representational State Transfer. I almost forgot the last one. Representational State Transfer. And everything I just described in terms of like get is read and put is update, blah, blah, blah. Those are the core tenets of REST. Basically, I'm explaining REST without telling you that's what it's called.
So that's what the APIs, that's what it said?
We're essentially describing the underpinnings of a REST API.
Like the whole, what we call the job, like that little data chunk, is there like a formal?
Yeah, in REST architecture, that's called a resource. Okay, so basically, the schema, model, class, it has like 8 different names. We just reeled off 4. So it could also be called a resource. Within the context of a REST API, we call those resources. Okay, so like it would be very typical to say how many resources are behind this API. Like that's a normal type of thing to look for. Okay. Okay, that's essentially REST architecture. So typically what happens is you as a server programmer, as a backend programmer, you would create like a REST API to serve data, resource data. Okay. Let's do that real quick. I'm just going to whip up a couple endpoints just so you understand. You can it's not just purely theoretical. I want you to actually do a little bit of it, so that you understand what it is what's supposed to be happening. So let's create a REST endpoint, a REST request path to get jobs data in pure REST form, in pure JSON form. So here, let me give you a real live example to make that a little bit more like concrete. I need a public Instagram account, if anyone knows one. Yeah.
The public Instagram account.
Okay, so LeBron James Instagram page, simple enough. Now, there is an API behind this that is providing the data that you literally see here. Okay, that API is returning data in JSON form. Remember I said multiple times that JSON is like the lingua franca of the web. Everything communicates through JSON. JSON is like the liaison to everything. That JSON, you can actually see it right here. If I do, this is JSON right here. This is the raw JSON data that's feeding the visual content you were just looking at. Okay?
What did you do? 84.1?
Yeah, let me just go back real quick. So I want to have these side by side. Here is what regular people see. Right. As a programmer, you should be thinking, what's going on over here? Constantly, you should be thinking that. Like, how does this part show up?
The movie Matrix is making more sense to me.
Yeah. Eventually, you'll just start talking in JSON, and your friends will be like, what are you talking about? Like, that happens. So, like here, this right here is one of LeBron James's recent posts. And that's got to be this guy right here. You see it? And that's what I mean by this is the literal JSON data that's feeding the content that you visually see. And as you do more and more programming, you have to start thinking like this. Like you got to sort of train your brain to start thinking like this, like all the time. Okay? Almost all REST APIs return data like this. And just to show you another example, more closer to home. Got a bunch of tutorials here. Do you think this is database-driven data? These tutorials?
50-50, yes.
Yeah, because I might add more. I might remove some because they're outdated. They live in a database. So what that means is there's a REST API endpoint that's providing the visual data you see right here. And that data that endpoint in this particular case is this right here. And you see how it's just more JSON, right? It's just JSON. That's all it is, right? And this is on my rinky-dink little turbo website. Doesn't get that many visitors. And this is on Instagram, which probably has 10 million visitors since I just loaded it, right? Probably more. And it's all using JSON. You see what I'm trying to say? Like it's that important. You need to understand how that data is organized and handled, which is what we're about to get into.
So REST is just can you repeat what REST is again?
Sure. So it's an acronym. It stands for Representational State Transfer. And essentially, everything I was describing in terms of get is read, update is put, create is put. That's the core philosophy of REST.
And then an API just reads REST.
No. An API is REST, or what they call RESTful or not. So in general, as a server programmer, as a backend programmer, if you're writing APIs, at least between 2010 and 2018 or 19, your job was to write REST APIs as close to REST philosophy as you can. So REST is not a Boolean. It's not like it's REST or not. It's not like pregnancy is a Boolean. You're pregnant or not. There's no in between. REST is more of a spectrum, and you want to get to as RESTful as you can. You want to maintain REST architecture as much as you can. Yeah, and basically what I'm describing are like the key principles of REST. There's a lot more to it, as always, but by and large, these concepts break down to a few bedrock principles that I hit on, and we just sort of go over it again and again and again.
So what is API again? It's like, it's just.
Yeah.
Is it
So-
like I've heard API requests?
Yeah, API is one of those. So kind of going back to your question earlier about like node versus like what is it a runtime or whatever. API is one of those unfortunate words that like has a technical meaning that the community has kind of diverged from in slang meaning. So there's like a textbook definition and like a slang definition. So the textbook definition of an API is literally the syntax and the verbiage behind programming a certain language, like the express APIs, router.get, and then your path, and then your argument, your function argument. Those are the APIs of the Express framework, but most people don't use the word in that sense anymore. Whenever you hear the word API thrown around now, they're talking about like a web API, a REST API. And that's what they actually mean, and that's more of a slang usage of the term.
Because I can't remember, like years ago, I went to one workshop where we pulled, I think I used the API like space image of the day or something, and we just uploaded that space image.
Oh yeah, I've seen that. Yeah.
So, but basically, they provided an API that just made this JSON file. Then we just import the JSON file.
Yeah.
That's
Okay, so obviously we'll revisit this, but I just want to illustrate kind of how these APIs and JSON come into play. So, this site right here is making at some point a request to that API data I just showed you. It's taking that JSON, it's doing what's called consuming that JSON, and then rendering it here. Okay? And that's how that works. So the first step of that process is making a request to the API for the JSON. And that's what we're about to create for this jobs right now. Okay, we're not actually going to need it for the actual website, but I just want to do it right now for a good exercise. This is something you should understand and something that you should be able to do at some point. So what I'm going to do right now, turn off the server, I'm going to create a whole new path, a whole new request endpoint to service the API for this job. Right? So who can guess what that means in terms of like what I do next? Like essentially, what should I do next to get that process started?
So, what you're saying is we're going to create. Can you repeat what we're doing?
I'm going to create a new request endpoint, a new request path, basically the same thing.
So
Create what? Paths are connected via what? Routes. So what do I need to create? A new route. Where am I going to create that?
In the routes.
Yeah, in the routes folder. What do you want to call it? There's no wrong answer here. Yeah, we can call it jobs. Give me more ideas.
occupations. I don't know.
Well, let's discuss that dichotomy. So we can call it jobs or occupations. But if we stick with jobs, then from a coder standpoint, it's very obvious, it should be at least, that this route corresponds to the jobs model and controller. So that's a good question. Like, what should we call it something else instead? You want to make your code readable such that some other programmer down the road can look at it and figure out, oh, that's what she meant. That's what she meant to do. Or more importantly, you can look at it 6 months later and think like, what was I thinking here? Oh, I must have been doing this. Right? So between jobs and occupation, I would advocate for jobs. But let's discuss a couple other options. Like what else can we go with? Same conversation though, right? Because it's jobs versus work. So I want to be very clear that, again, there's no necessarily wrong answer here, but as a programmer, these are the things you have to I'm debating this stuff all the time. Like, what's this? Is this a good naming convention here? Will other programmers understand? Programmers currently on my team. Like, I don't want to make their life harder, right? Otherwise, they're not going to like me. So I have to figure out how to make their life easier, right? So another more general naming could be just API. We can create another route just called API, which can service like all the API routes. But that's not to suggest like the jobs route is a bad name, right? We could have 10 different routes for 10 different resources, all servicing the API. You could do that too. It's up to you. And it's really a question of what's more maintainable, what's more readable. Okay?
So you would only have one API per site? Or could you?
Come in?
Like, when you're saying, so like, maybe I'm confused. You can have one site has one API, or can you have?
No, you can have multiple.
You can have
Yeah.
multiple.
So I'm going to cd to the routes folder. Everyone do this with me. Actually, I'm going to get away from the terminal. I'm going to do everything in VS Code. So in the actual routes folder, like Kia said, let's create a new route here. I'm going to create a new file. Let's go with Tina's jobs, suggestion, jobs, okay? And then I'm going to open up the index route just to get these imports in here. This is what we call boilerplate code, meaning like it's going to be the same all the time. And then I'm just going to do this last piece of boilerplate. And I promise this is the last time I'll just like gloss over it. Next time I'll actually go through all this. Okay. And then the first thing I'm going to do is connect a get handler. A get handler. Just for the purposes of testing. And inside here it goes rec and res. And then here I'm going to send back just a dummy test response. This is the jobs API endpoint. By the way, I'm using the word endpoint and like route interchangeably. They're fundamentally the same thing, but I would say endpoint is like the more popular terminology. So like when you go to www.whatever.com, you're doing what we call a hitting an endpoint. You're hitting an endpoint. That's like the fancy way of saying you're visiting a website. You're hitting an endpoint, okay? I kind of went fast on this. I'm going to leave it up. I went fast just to give myself more time to explain and talk. So make sure you have this properly copied. So we have a jobs API route. Another thing you could have done is jobs-API.js. Just different ways of making the code more readable. Okay. And we connected a get handler right here, and that get on line 6 is a direct reference to what? We talked about this on Wednesday briefly. So the way you want to think of line 6 is the following. Routers handle HTTP requests. That's their job. That's what they do. They handle HTTP requests. HTTP requests have a variety of types, 4 types in particular. What's the most important one?
Yeah.
Say it louder.
Yeah.
Get, the get request. So on line 6, we're telling the router, we're saying, hey router, for all get requests, do this. And that's this right here, do that. Right. So we're telling the router, hey router, for all get requests, I want you to respond with this. That's how you want to think of it, okay? That's how routers work, okay? Now we created a new route, but we didn't use it, right? This is a route that has not been used anywhere. So what do I do next? link it. Where do I do that?
The view?
Mm-mm. Look at your notes if you have to. This isn't a test. But I do want the answers out of you, so. So we created a route here, right here, jobs.js, but we just created it. We didn't use it. It's not connected anywhere. We need to connect it. We need to link it, as Nicole said.
It has the acronym, right?
So the question now is, where do we link it?
So it's MCV, models, controller views. Right?
That's not where. That's a concept. It's MVC, by the way. That's a concept. But what I'm literally asking, where in the code should I go next?
To the controller. Right?
That's not where you connect routes. Where do you connect? Where do you import routes?
In the must.
In the JSON.
Yeah, don't guess.
Yeah,
Don't guess.
so let me stop guessing. So this was her route.
Yeah, look it up if you have to. Like I said, this isn't a test.
Routes are dictated by the path.
True, but where do we connect the routes?
It's such a simple question.
It's in the code too. It has to be connected in the code somewhere.
Is it in the module?
Don't guess, Rashid. I'll give you a clue. There's a line in the code, literally somewhere in the code, that says import the routes. App.js, import routes on line 21. This project so far only uses one route, the index route, right? So we need to expand that. So we need to create, we now need to import the route we just created. So right here on line 23, what should I type next?
Basically the same thing except /routes.
Yeah, well, read it out to me.
So const index equals.
Oh no, you said basically the same thing, not literally the same thing.
Okay.
That's why I said read it out to me.
So index isn't next.
That would actually be incorrect because we already have an index route right here. Right, that would actually not work at all.
Oh, because it's a constant, so you could just make it like jobs.
Jobs, right? Because what's the name of this route?
Jobs.
Jobs.
So equals require
And then what?
dot routes jobs.
Correct. So now, excuse me, we've imported the jobs route. We've imported the route we just created. Right, we've imported it. But we still haven't done what you said, Nicole. We still haven't linked it. Right, so where do we do that? Or in the code you see here, we still haven't set the route.
Path used.
Good. Now inside here, those question marks is an argument that determines what? the path. So what do you think I should type there?
I mean, we only have one homepage, right?
Yeah, the homepage is done. That's done on line 26. So we don't want another one, right? That's going to overwrite the first one. That'll blow away all the work on the homepage.
If we use that class that we defined, like that class or that, we want to point to the specific spot on the homepage, right?
No, we don't want to do that. Right now we want to connect a route which renders the JSON data of a job. But even that's too far right now. We just want to send back that sample response. This is the jobs API endpoint. So again, these question marks right here determine the path which will trigger the route. So we have to decide what will be a good path. What will be like a sensible path.
So /jobs,
And then comma, what do I type here?
the constant name.
Which is jobs. So on line 27, I'm assigning a new path to the website. So localhost 3000 and then /jobs. And that when I visit that path or when I hit that endpoint, I'm going to invoke the jobs route that we just wrote. And if we did our job correctly, we should see this.
But this is a single page, right? So don't we only have a homepage?
No, we just added a new page.
Oh, so we just literally add, so like now we'll have another.
Well, hopefully, assuming we made no mistakes.
Okay.
So let's find out. So I'm going to run the dev server.
I thought we were just like auto-populating or creating a new way to populate the single page.
No, you're going way too far. We probably won't get to that till next Monday. Right now, I kind of took a detour to show how to put together like a JSON-based API because it's a very important skill. It's not necessarily required for this particular website, but it's important enough that I decided this is something we should devote time to. So I have the dev server running. Go to localhost 3000. That's the same. I haven't really tested anything. What do I need to do to test this?
/jobs.
And then before I hit enter, what should I see?
Just the JSON.
No, literally, what should I see? What are the exact words I should see?
This is the endpoint.
This is
It's
the,
a job endpoint.
yeah,
I can't remember the exact verbiage, but it should say the job.
this is the jobs API endpoint. So we have successfully connected a new route, right? So that's good. Now we're ready to go. So basically, what we've confirmed is that this route works. Great. Now we're ready to actually do some actual work. You guys with me? So let's go ahead and do that. So I'm going to turn the server off. It says jobs. Jobs. Okay. So instead of this sort of dummy response here, right? Like it's nice that we get that working, but that's not really what we want. We want to see in that endpoint, we want to see all the jobs currently in the database in a certain format. In what format?
JSON.
JSON. Good. We want to see something like this, right? And this represents all the data in the back end, at least in this case for tutorials on Turbo. But again, that's not a Turbo thing, like I showed you with the Instagram, right? Even Instagram does it this way, right? And every other major website, Google does all their stuff this way, and Airbnb, whatever. So here, let's get rid of this. We've confirmed it worked. So what we need to do here, I'm going to put a little note here, fetch all jobs currently in DB. This is a good practice because what tends to happen, especially with beginners, is you get so buried in the work you forget what you're doing in the first place. And so you put that little note there to remind yourself that's the goal. Okay? Render as JSON. Okay. It's a good habit. Get in the habit of doing that. It'll make you a better programmer. So let's get rid of this. Now, if we're getting all the jobs from the DB, the backend, what part of the CRUD are we doing?
We're getting all the jobs.
So CRUD, which letter in the CRUD are we doing? Read. We're reading it. Okay. So the CRUD operations in this project are controlled by controllers. So we need to grab the controller and then read the jobs. Okay, so we do, this part I'm just going to kind of gloss over because we'll get to it on the next one. Except it's not a post, it's a job. Okay, so I'm grabbing the job controller from the controller's object. And the syntax may seem a little screwy at first. I'll explain it probably on Monday or Wednesday of this week. So right here on line 10, that's the controller. Okay? And we need to get the jobs. So if you open up the jobs controller, you may recall on top, the function here on line 10 is literally get. That's a function, right? So that's the function we need to run off the controller. Or to put it another way, we need to grab the controller, then run that function. Well, we just grabbed the controller. We did that, right? So now here it is right here. So now we run that function. So what do I type next? What's the name of the function? Get. Get. Now it's a function, which means you need the parentheses, like that.
Jobs in there?
That function will return all the jobs in the database. Which right now, if you go back to the site itself, you'll see there's 2 jobs, president, senator. So we should see those 2 jobs come out in JSON form. Okay? Now the syntax here is a little screwy. It's going to be a then right here, which is pretty much what it sounds like. Do this next. And inside the parentheses is the result of the first function, get. So we do jobs. Like this is the payload of that function. And then you open up another function closure, function block. And that's the data we want, right? That's all the jobs. So we want to return that data in JSON form. Okay, so we do res, because we are now returning data. We're now responding with data. Okay? But we don't render, we don't send. Now we respond with JSON. Res.json. That's a function, so you need the parentheses. And then you just insert the data you want to return as JSON. In this case, 2 jobs, 1, 2, hopefully. So let's try it out. Make sure you save the file, right? Remember, if you see that circle up here, it's not saved. So you do a save. And then I'm going to run the dev server. And then head over to localhost. I'm back here at the test endpoint, but now when I reload, what should I see? Those 2 jobs, hopefully. Biggie bam. See it? And do you guys see that happening on your end?
I'm having issues with the CLI. It's like when I do
Okay, well, we want at least 1 or 2 people getting this. Is important, so, you know. I'll wait. But
Could you go
Yeah.
back to the code?
I had a typo, so.
okay, let's get this part. I want to make sure at least one person gets this one. Okay, so here's the JSON data of the jobs currently in the database on our project. Just to show you a little bit more kind of how this connects, this code works, but it's not complete. Here, basically, we're assuming this code will never crash. Right? That's obviously not a good idea. So basically, whenever something goes wrong, we want to implement what's called a catch block. Remember what I said last time? The word catch here essentially means just in case. So in case something goes wrong, you want to have a catch block there saying do this if something goes wrong. And the catch block usually has an error object inside, which should give you some indication of what went wrong. So that might be like the database is down. Right? Typically, a database is on a separate server. The database connection might have been corrupted. The database itself might be down, whatever. So we have an error object here, which should give you some indication of what went wrong. And then you run the block. And here, what I normally do is send back some JSON with a message saying error message. Error object should have a message key attached to it. And we can just send that back. Okay. This is just for the sake of thoroughness, but let's say I deliberately induce an error. So like this word jobs controller.get, I just deliberately misspelled that. That's going to crash. That should be an error, right? So if I run the query, let me just run the server. So I run the query. Well, didn't run the catch block, but you can see what's going on here, right? It's telling you what went wrong. This is called a stack trace. Technically, it didn't run the catch block. So let me actually induce the catch block. So here, let's say I misspelled JSON on purpose. You see that? That's the catch block. You see how it's returning the JSON response that we wrote. And it's giving us an indication of what went wrong. He said JSON is not a function. By having these catch blocks properly located in your code, it'll make your life 1,000 times easier. Because if I didn't have this catch block in here, if I just left it off, I just forgot, right? I won't see this. I'll probably see a stack trace. And a stack trace, or it just, nothing happens at all. See, look, it's hanging. You see, the code right now is hanging. So like, this is the worst kind of bug. Because you might have like 10,000 lines of code in there, and you're like, I have no idea where it's hung right now, right? So by having these catch blocks properly situated across your code, it'll make your life. You're doing this for yourself. I want to be very clear about this. You're doing this to make your life easier down the road. Okay, and then you can quickly see the errors, like, oh, I misspelled JSON, let me go find it, fix it, back to work, right? And then that's how you should be thinking, okay? So now we're back in business. I'm going to show you one more thing here. Well, the jobs isn't particularly a good example, but let's say you had like a history of 10,000 jobs for some odd reason, right? You might not want to return like all 10,000 on this query, right? That would be kind of a bit much on the database, right? So what you want to do is pass through filters, query filters that can sort of make the response more manageable. That can give you some control over the response data, right? So let's say I only want the one most recent job. Basically what I'm saying here is I want to limit the result set to 1, okay? I only want the most recent job. So what I could do is pass in a query filter, or sometimes called the query parameter, in the URL, right? And that's done in the form of a question mark at the end of the URL, question mark, and then limit equals 1. And that becomes a query filter or a query parameter. Okay, that query parameter is then passed to the Node Express request object. So far we've basically been working with only the response object, right? But now we're going to deal with the request object. This whole thing right there is the request. So it gets passed to the request object in the Express router. But as the programmer, we haven't done anything with it. We basically ignored it. So we need to grab the query filter in the request object. You see that on line 8? The request object contains those query parameters. And it's literally called query. So we do const filters equals rec.query. This object right here, .query, is a JSON representation of this query string right here, question mark limit equals 1. You see that? Question mark limit equals 1. That's the query string. But this query key, this query object, will return that string in JSON form. So it's going to give us a JSON object saying limit : 1. And just to reinforce that, there's many ways we can reinforce it. So I'm going to put it back here in this response object. So what I'm going to do is take out this jobs. I'm going to insert a whole new JSON object. I'm going to put back the jobs payload. And then I'm going to add a new key called query and pass in the filters from the query parameters. So basically, we're taking the query parameters and just spitting it right back. We're still doing nothing with it, but just sending it right back to the client side. So if I go back here and reload, I still get my jobs, but look at the query filter down here. You see it? That's the JSON object, limit 1, that's coming from here. Right, so if I put in 10, it's going to say limit 10. Right, I'm just passing it right back. That's all I'm doing. Right? It has, as of now, it has no impact on the actual data payload. We're just sending it right back.
How do you make it have an impact?
Yeah, that's the next step. So if you go to the controller, you'll see in the get function that we're using, it takes an argument called params, which are filters. It's a JSON object. So we could just pass that in to the function right away. Just pass it in. So those filters are now being passed into the query, which means it should now take effect. So if I put in a limit of 1, this time when I press return, I should see 1 job, not 2, right? 1. For some reason, I lost the filters here, though, so let me just find that. Yeah, you know what? I'm not going to worry about it. It's not that important right now. All right, what matters is this filter is taking effect. All right, so if I put in 10, I'm not going to get 10 jobs because 10 jobs don't exist. I'm only going to get 2. Now, those filters can be applied to any attribute on the schema. So let me repeat that. those filters can be applied to any attribute on the schema. So let's say I want to find the job that I worked at in Boston. I do question mark location equals Boston, and that will return the job that I worked at in Boston back when I was Senator of Massachusetts in 1953. Do you see how that works? Let's say I want to find the job in my job history, which was in Chicago. What's going to happen here? So what am I going to get? Right, because I didn't work in Chicago, or JFK didn't work in Chicago. So I get an empty array, a list of empty objects, or an empty list. Let's go back to the Boston example. Right, there's Boston. Now watch what happens here. If I type in Boston with a lowercase b, lowercase b. So this is giving, the browser's giving me grief right now. Lowercase b.
That doesn't.
Right, it's case sensitive. So this is a situation where you might want to use the lowercase equals true option. Because I might enter Boston with a capital B when I'm filling out my jobs history. Very typical thing to do. But the filter might be looking for lowercase. So if you just standardize all your data saying no matter what, all cities come in as lowercase, no matter what, then these little things won't happen. Okay, these little things are very common mistakes among beginners, where they're like,
If you write it in B, but say, if it's lowercase, write it in capital, but say if it's lowercase equals true, and then the capital and the lowercase will be accepted.
no, almost. The capital will be taken in, but it'll be automatically converted into lowercase. Okay, and that'll only happen if I do this. If I go back to my schema, this is the guy that's causing the trouble, location, right? So the next thing I would do is lowercase equals true.
Could they also do uppercase equal true?
Yeah, same thing. It'll opposite effect. And then that'll guarantee that no matter what the user types, no matter what, it'll come in as lowercase. It'll be transformed to lowercase. Little things like that are worth pointing out. I'm not going to make a big deal of it right now, but I just want you to know, like, that's why we would use it. So somebody might ask, like, why would we want everything to be lowercase? Like, there's a very good reason for it, and this is a situation that's happened to me a lot in the past. So here, we just get all the jobs. Okay? And then I'm going to implement one more just for good measure, and we'll call it a night. So let's say I want a specific job. I want a query for a specific job I had in mind. Remember, like I said before, like I asked you what was your first job out of college, and you're remembering a very particular job that it was a specific job. And in the controller, which query would that be? Let me collapse these. So these are our 4 functions in the controller. Which one do you think I want to use to get a particular job? Get by ID, line 25, right? And you pass in the ID. That ID is this number right here. This is the unique identifier. And that's what I meant by the database will automatically create it for you. Okay? So what I would do is I go back to my jobs route, and I would create another route for this guy. Now, one thing I cannot do is this. I cannot do that. Can anyone tell me why?
Because you don't have ID.
Isn't get a separate function?
Close, yeah. Whatever comes after here has to map to an HTTP method. That's what they completely revolve around.
And it's just matching to an ID.
Right.
So-
Is get by ID in HTTP method. Does not exist. It has to be get also. It's just another type of get.
There's-
And then you pass
it
in
just
the,
focuses on the user identity.
right. Now, the problem here is that I now have a route here on line 8 that's get slash, and another one on line 25 that's get slash. That's not going to work. The second one is going to supersede the first one. Basically, the first one will just be overwritten. We don't want that, right? That's bad. So we need to add more specificity to the path, and that will distinguish one from the other. So what we can do here is add what's called a request parameter. And the way you do that is by adding a colon, that's very important, and then the parameter ID. And now we've created a second get handler in the same route. And there's no conflict between the two. They can both coexist peacefully. And this parameter right here is part of the request. So we can just grab it. Const ID equals rec params ID. Parameter dot ID. Okay? So this ID represents whatever, I wish those things would go away, whatever text we put after the slash. So it's going to be localhost 3000 / job / whatever. And everything that comes after that is the ID. And then we do the same thing we did before. We grab the controller. And we run the query. But this time, what query are we going to run?
Get ID or get that ID?
Which one?
Get by ID.
Get by ID, this guy. And notice how it takes an ID parameter, an ID argument. So we just run that function and we pass in the ID, this guy. Okay? So we grab the ID from the request parameter, and we pass it off to the controller. And then the controller is going to do its thing, which is going to get the corresponding job based on whatever ID we pass in. And the rest of that process is basically the same. There's a then, like the next, what do you do next? The then. And that's going to return a job. Why is it not jobs this time? It's one, not many. So we return the JSON this time, and we return the job. The important thing here is to remember this is the path. So we do localhost 3000 / what? / jobs, and then another slash, and then the ID.
So the end of the jobs looking for the ID of the particular.
Yes, you got it. So here we have all the jobs, right? And these are the IDs. So I'm just going to grab the second one and copy that. That's the ID. So I'm going to open a new tab and go back to localhost 3000, and then / what? Jobs, and then /.
Well, you put in the ID. You put in the ID, but you
Right.
just
I paste in the ID that I copied, and that returns the one job that corresponds to that ID. Okay. Is this making sense?
Yes.
Okay.
I'm gonna have to watch the video.
Yeah, definitely watch the video again. It's fair to say, I would say so far, this is the most important topic we've covered so far in all the workshops. So go home and make sure you understand this. We're building out the base level of a REST API. Okay, so I would call this, I would say this is not an exaggeration to say this is the most important thing so far that we've reviewed in all the workshops. So if I go back here and I just type in gibberish, what's going to happen? Not going to get anything. Now, in this case, it's going to throw back an error because this job doesn't exist, right? So it would be like me asking you, hey, what job did you work while you were in 5th grade? Hopefully you didn't work in a job, but you get my point, right? Like no, I didn't work a job in 5th grade, right? But if you go back to the code, what did we not do? The catch block, the just in case block. So if I run the code now with this nonsense ID, hangs again. Right? We did not appropriately handle this situation. That's called error handling. Okay, we did not appropriately handle this error. We didn't handle it at all, right? And so this guy is just going to keep on spinning for probably about another minute. Eventually it's going to say, no bueno. But in a real production environment, like in an actual server, your server will crash. And then your whole website will go down. Like the consequences are a bit more serious on a production environment, right? So you need to handle errors, right? That's very important. So I go back here and I implement the catch block, right? And that gives us an error. That provides us an error object, which hopefully gives us some sort of intuitive error message. So I respond in the catch block, I respond with a message. And that message hopefully is in the error object right there. Okay? So now on the endpoint that's broken, this is the code that should run. So I go back here and I try it again. Job not found. Because it's literally not found. It's not there. And this is the catch block doing its job. It's what it's supposed to be doing. Okay.
Sounds like the most important thing.
Yes. Yeah. If you don't properly handle errors, you're not making other people's life harder, which you are, but you're making your life harder. So if I don't have this catch block and I'm on line 4,000 of this code base and this sucker runs without a catch block, I just put myself in a world of hurt. Because I got to go through all that code and figure out what's what. But if I see this right away, within 30 seconds, I'm thinking, all right, it's searching for a job that's not there. Where are the job request queries? Find those, narrow it down to which one's looking for the ID. It's going to be just one. The mistake is in here somewhere. And that's through 10,000 lines of code. You can still do it that fast. But if you don't have the catch block, you're just looking at a vast ocean looking for a bottle. And you're just like, where could it be? And that's no fun. Okay? Okay, we went a bit long tonight. We want to finish this API endpoint on Wednesday. But between now and Wednesday, try to get this working on your side because this is important. We're just going to continue this. So if you don't have this working by Wednesday, pretty much right from step one, you're going to be lost already, right? Or you're going to be behind, I should say. None of you are lost, you're just behind. So try to get it working for Wednesday so we can finish this out. And then we can wrap it up by going back to the actual site and going through how those concepts are being employed in this site, and then using that for us to make this more personal for our own resume. Okay. Actually, one last thing, just for good measure, I'm going to deploy it so we can see it working in the cloud as well. And then I should be deploying more frequently, to be honest. I just forget. But you want to make sure before you kind of find a good closing point, you want to deploy and just make sure everything's working where it's supposed to be working, and then you close out your day. Like you're done that day. As a general rule of thumb at work, what you want to do is whatever code you worked on that day, you want to do what's called checking it in. You want to commit that code to what's called the repo. And that code, in an ideal scenario, should be working code, but that's not always the case. Sometimes you're stuck on a really nasty bug. But ideally, that code should be somewhat working. So here is the staging deployment. So I want to test the endpoint that I just wrote. What do I do? Slash what? Jobs, right. And here's the API response in the cloud. I can test the limit filter. There it is. I can grab the second one, grab the ID, pass the ID through, and there's the second one. And while we're on it, so this is the admin dashboard for the site. I can just go here, click on CMS. Here are the two jobs. I'll just add one right now. Software developer, Google, Mountain View, California, 2000. This is in the future. I rewrite their search engine.
Should put sound video too.
Okay, so I'm adding a new job to the API. So there it is right there, right? So that's my new job in 2 years. So I'm going to go back to the cloud, the staging environment, and this returns all the jobs. Google. Good? And it shows all the stuff that we just added.
What order does it do it in? The order
Most recent first.
Most recent.
Okay, that's called reverse chronological.
Which is based on the timestamp, right?
Yeah, so this is the timestamp, and this is like the human readable version of the timestamp. Okay.
But then if you want to filter it by the actual like end date or start date.
End date. Let's see that right now. So
Or
the,
not filter, but display it in order.
oh, yeah. I forget the name of that. The order of the response. I can show you how to do that on Wednesday. Like let's say you want to filter it like by alphabetical, for example. Like that would, you have to structure your query in such a way to pass that through to the database search. Okay. We'll discuss all that on Wednesday. Okay, good. So this worked in the cloud too. So again, make sure when you go home, try to get to this point. Okay, get it doing what it's doing here, and then you'll be in the right spot for Wednesday. Okay. Thanks for staying late.